the notes for lesson 3.5, graphing linear equations in 3 variables. So we've talked about solving linear equations and solving systems of equations. Now we're going to add one more dimension. So we've been looking at 2 dimensions, now we're going to look at 3 dimensions. So a 3D coordinate system is a coordinate system determined by 3 mutually perpendicular axes. The 3 axes divide the coordinate system into 8 parts, or octants. An ordered triple is the coordinates required to graph on a 3-dimensional coordinate plane, so x, y, and z. And the 3D coordinate equation is ax plus by plus cz equals d. So if we look at the image on the left here, this just kind of shows what we are looking at. So we have our x-axis, which is almost coming out towards us. We have our y-axis, which is going left and right. And we have our z-axis, which is going vertically up and down. So as you can see, this octant where these coordinates come together to form a point. So on the right-hand side here, we have our 3-dimensional grid that we will be graphing on. So again, the x-axis is the one that looks like it's coming out at us. If we go towards us, we know that that is positive. And if we go backwards, we know that that is negative. Our y-axis is left and right, so horizontal. Again, if we go to the right, it is positive. If we go to the left, it is negative. And lastly, our z-axis is up and down or vertical. If we go up, it is positive. If we go down, it is negative. So again, we are solving just like we did before, or graphing just like we did before, only we're adding one more dimension to it. So example 1, we are graphing the 3-dimensional points below and labeling each point. So again, we're looking at how to graph each of these points in 3 dimensions. So if we look at letter A, we have 1, 2, and 5. So again, this is x, y, and z. So on the x-axis, again, we start at the origin just like we always do. So we're going to go on the x-axis positive 1, so it's going to be 1 towards us. Then from that point on our y-axis, we are going positive 2, so we're going to go to the right 2. And lastly, z tells us positive 5, so we're going to go up 5. So we're going to end up at the point right here. So again, our x, we went 1. Y, we went positive 2, or right 2. And then z told us to go up 5. So that's kind of the path that we got to get to the point A. Our second point is negative 2, 3, negative 3. So again, we start at the origin. The x-axis, we are going negative 2, so we're going to go back 2. Y tells us to go positive 3, so we're going to go to the right 3. And z tells us to go negative 3, so we're going to go down 3. So B is going to be right here. So again, negative 2 told us to go back 2. Positive 3 told us to go right 3. And negative 3 told us to go down 3. So again, the x value, we're going towards us or backwards. Y is left and right, z is up and down. The last point, 0, negative 2, and 5. So if we're going 0 on the x-axis, we're staying at the origin. Negative 2 tells us to go left 2, and positive 5 tells us to go up 5. So our C is right here. So again, plotting points for 3 dimensions is very similar to 2 dimensions. We're just adding that extra axis. So we looked at plotting points in 3 dimensions. Next, we are going to look at writing or graphing lines in 3 dimensions. So this is the equation for a line. Notice we have 3 dimensions or 3 variables, x, y, and z. Now to graph this, if we changed it to slope-intercept form, we would have an extra variable, so we have that z in there. So the easiest way to graph when you're in 3 dimensions is to find your intercepts. So you're going to find your x, your y, and your z intercepts. So to find your x-intercept, you want to make y and z 0. So if you recall from the previous chapter when we were graphing lines, to find the x-intercept, we would make y 0. So in this case, we're going to make all of our other variables 0, and then we'll solve for x. So if we start with our x-intercept, again, if we make y and z 0, they are 0, so we're just left with 3x equals 12. To solve for x, we divide by 3, and x equals 4. Then we also need to find our y-intercept and our z-intercept. So to find our y-intercept, we make x and z 0. So we are just left with 2y equals 12. Again, divide by 2, and y equals 6. And then lastly, our z-intercept. Again, if we make x and y 0, we are left with negative 4z equals 12. Divide by negative 4, and z equals negative 3. So then we're just going to graph these 3 points on the graph, and then we're going to connect them. So we're going to start on the x-axis. This is a positive 4, so it's coming towards us. So this is the point right here, positive 4. Y equals 6, so on the y-axis we're going to go over 6, and z is negative 3, so we're going to go down 3. The solution is a triangular region of the plane that lies in an octant. Remember, we talked about on the previous page, in 3 dimensions, our graph is split into 8 different parts, or called octants. So again, this is a triangular region that lies in one of those octants. So what we're going to do is connect these points, and notice we form a triangular region, and we do usually shade it in. So again, to graph the equation of a line when we're in 3 dimensions, we need to find each of our intercepts, connect those points, and it's the triangular region that the plane lies in. For example 2, we're writing the linear equation as a function of x and y. So essentially we are solving for z. So we want the function to just be in terms of x and y, so again, solving for z. Just like we would in slope-intercept form, we'd solve for y. We're doing the same type thing, but we are solving for z this time. So to get z all by itself, we first want to add 2x to both sides. That leaves us with negative y plus z equals 2x plus 7. And then lastly, we are going to add y to both sides. So that gives us z equals 2x plus y plus 7. So z equals 2x plus y plus 7. Now we could also use function notation. And function notation in 3 dimensions is written as f of xy equals 2x plus y plus 7. So again, you can write this either way, either z equals or f of xy. F of xy is just your function notation. So in the second part, we are evaluating the function when x equals negative 3 and y equals 2. So we're just plugging in these 2 values into our function. Again, in function notation, this would look like f of negative 3, 2, because negative 3 is our x value and 2 is our y value. And again, we're just plugging those values in. Since x is negative 3, we have 2 times negative 3 plus y is 2, so plus 2, plus 7. 2 times negative 3 is negative 6, plus 2, plus 7. Negative 6 plus 2 is negative 4, plus 7 is 3, so this equals 3. So we can write this as z equals 3, or f of negative 3, 2 equals 3. Again, one is standard notation, one is function notation. Example 3 says you are buying daisies, roses, and a glass vase to make a flower arrangement. The flower shop sells daisies for 82 cents each and roses for 49 cents each. The glass vase costs $12. Write a model for the total cost of the flower arrangement as a function of the number of daisies and roses you use. So first we need to assign our variables. So we want to know how many daisies and how many roses. So the number of daisies is going to be x. The number of roses is going to be y. We know that every daisy is 82 cents per daisy. So this is z equals 0.82x. So again, the cost times the number of daisies. Plus we know that every rose is 49 cents. So 0.49y would give us the cost of our roses. And then we also know that we're buying a vase that is $12. So we're just going to add that onto our cost. So this is our function that we are going to use, and then we want to evaluate for 6 daisies and 2 roses. So we want to find out what our cost would be if we bought 6 daisies and 3 roses. So we're just going to plug those in. So we're going to plug in 6 for X, 3 for Y. So 0.82 times 6, because that's the number of daisies that we are buying, plus 0.49 times 3, because that's the number of roses, plus our $12 vase, and then we can just evaluate. If we plug this in, you should get a total of $18.39. So if we buy 6 daisies and 3 roses, it's going to cost us $18.39. So again, with 3 dimensions, it's very similar to 2 dimensions. We're just adding that extra variable in each time. We're just adding that extra variable in each time.